Hello students, I am Sachitrakar. Welcome to Cars Physics. In this lecture we will discuss relative velocity. Relative velocity in one-dimensional motion. Relative velocity in one-dimensional motion, and this is part 1 of the lecture, and thereafter we will discuss relative velocity in two-dimensional motion. First we will discuss the theory behind relative velocity in one-dimensional motion. Thereafter we will approach some numericals on the theory. Thereafter we will move to relative velocity in two-dimensional motion. Again we will approach beautiful numericals on the basis of relative velocity in two-dimensional motion. In this lecture we will discuss first the theory behind relative motion in one-dimensional motion, means relative velocity in one-dimensional motion. Okay. So, what is relative velocity? First question arises, what is relative velocity? So, from very beginning, means in lecture 1 of kinematics, I have discussed all conditions of rest and motion, all conditions of rest and motion are only relative. It means absolute rest or absolute motion is not possible in this universe. Means nobody is at absolute rest or nobody is at absolute motion. All conditions of rest and motion are only relative, means relative rest and relative motion. All conditions of rest and motion are referred as relative rest and relative motion. Nothing in this universe is absolute. Okay. Again, another basic concept I have discussed. The state of rest or motion of a body. State of rest or motion of a body depends on the state of observer and frame of reference. These are the basic concepts of kinematics. All conditions of rest and motion are only relative. It means absolute rest and absolute motion are not possible in practice. Means all conditions of rest and motion in this universe are only relative. Okay. Then the state of rest or motion of a body is observed by an observer. Okay. The state of rest or motion of a body depends upon the state of observer and frame of reference of the observer. Okay. Depends on state of observer and frame of reference of the observer, and we have discussed in brief on frame of reference. Okay. Frame of reference means which is used to describe an event completely. Frame of reference contains 4 coordinate system to describe rest or motion in space. Means space coordinate system, 3 for position and 1 for time. 3 for position and 1 for time, means 3 coordinates are space coordinates and another coordinate is required, that is time coordinate. Okay. So frame of reference, we have taken different examples. I am standing in this hall. Okay. This may be taken as frame of reference. Okay. Suppose a person is traveling inside a bus or inside a train or inside a car, then that's also considered as frame of reference. So these are basic concepts. Then our discussion is relative velocity. What is meant by relative velocity? So as we have discussed, nothing in this universe is absolute, but everything is relative. Okay? But relative velocity, what is basic definition of relative velocity? Okay? Relative velocity is defined as velocity of a body with respect to another body. With respect to another body. See students, this is a discussion on relative velocity, and this is part 1 of this discussion. We will discuss first the theory behind relative velocity in one-dimensional motion. Thereafter we will approach numericals. Okay. Thereafter we will go to discussion on relative velocity in two-dimensional motion, and we will do some beautiful numericals as I have told you. Okay. So relative velocity is defined as velocity of a body with respect to another body. Velocity of a body with respect to another body, or velocity of a body with relation to another body. Okay. So with relation or with respect to another body means this body is observer. This body is observer. Who observes? Velocity of a body with respect to observer, okay, or with relation to observer. Is it clear? Is it clear to all? Okay. Then what is method of calculating relative velocity? The basic thought, how to calculate relative velocity in one-dimensional motion. How to calculate relative velocity in one-dimensional motion. This is basic definition. Okay. Can I erase it now? Okay. Let's take some assumption. This is basic theory. Let a body A. Name of the body is A. Let a body A is moving with velocity VA. A body A moving with velocity VA and a body B moving with velocity VB. Okay, let's consider two bodies A and B. A is moving with velocity VA and B is moving with velocity VB. Okay, then how to calculate relative velocity? We have discussed the theoretical concept behind relative velocity, velocity of a body with relation or with respect to another body. Then how can you calculate? Means quantitatively how can you calculate relative velocity? So velocity of course, so we may take body A is moving with velocity VA with respect to ground. Okay, with respect to ground, and body B moving with velocity VB with respect to ground. Ground is at rest. We have to assume like that. So earth is moving, but we do assume that ground is at rest. Body A moving with velocity VA with respect to ground. Body B moving with velocity VB with respect to ground. Okay. All are with respect to ground. Then velocity of body A with respect to body B is given as VAB. You will read it like this. This is velocity of A with respect to ground. This is velocity of B with respect to ground. Then velocity of body A with respect to body B is given as VAB. We will read like this: velocity of body A with respect to body B. Then how to calculate? Relative velocity is calculated by the method of vector subtraction. Relative velocity is calculated by the method of vector subtraction like this: VA vector minus VB. VA is a vector quantity, VB is a vector quantity. Why do you take this method? Means why do we calculate relative velocity by taking the method of vector subtraction? I will discuss. Okay. Similarly, velocity of body B with respect to body A is given as VBA. We'll read like this: velocity of body B with respect to A, and in similar way we can write it velocity of body B minus velocity of body A. This is also method of vector subtraction. So how to calculate relative velocity? By taking the method of vector subtraction. Velocity of body A with respect to B is velocity of body A minus velocity of body B. Velocity of body B with respect to A is velocity of B minus velocity of A. Why do you take vector subtraction? I will explain while representing vector diagram. Is it clear so far? Okay. Let's consider then from derivation base, the fundamental derivation. Let's calculate either of them, either VAB or VBA. Let's calculate VAB, velocity of body A with respect to velocity of body B. Okay. Then what is the method? V minus V. So as you know, the method of vector subtraction is equivalent to the method of vector addition. Okay. Then this may be written as V plus minus VB. Means in vector subtraction, negative of one vector is added with other vector. Negative of one vector is added with other vector. To have derivation, we may take two-dimensional method, but finally we will discuss the numericals on one-dimensional method. Thereafter we will go to two-dimensional method. Okay. Let angle between V and VB is theta. If theta is either 0 degree or 180 degree, if theta is either 0 degree or 180 degree, then it is one-dimensional motion. If theta is either 0 degree or 180 degree, then it is one-dimensional motion. Okay. For any other angle, we may consider two-dimensional motion. Okay. Let's consider theta is any value, not 0, not 180. Okay. Any value theta. Means we are representing like this. Let this is let this is direction of velocity of body A, and this is direction of velocity of body B, and this is theta. Suppose A is moving along east and B is moving, making an angle theta with velocity A. This is not one dimensional. This is not one dimensional motion wave. Okay. So, one dimensional means either along x-axis or along y-axis or along z-axis, but this is not one dimensional motion. For derivation purpose, I am taking like this. Okay. Then what is our method? VAB is equal to VA plus minus VB. The method of vector subtraction is equivalent to that of method of vector addition. And finally, we will discuss motion in one dimension, relative velocity in one dimensional motion, taking theta is equal to 0 and 180. Just have a fundamental derivation. Then, minus VB is added with V. If this is VB, then as you know, length of line represents magnitude of vector, arrow mark represents direction of vector, then the same length of line is produced in opposite direction, then this is minus VB. Okay, this is minus VB. Okay, now angle becomes 180 degree minus theta. This is also VB, velocity of body B, but makes an angle 180 degree minus theta with A. We have to add minus VB with V, complete the parallelogram, or you may take triangle. This is diagonal. The magnitude and direction of relative velocity VAB is represented by the diagonal. Okay. Then let this angle is alpha. Now it is simple. What is formula for VAB? As you know, is equal to square root of VA square plus VB square plus 2 VB cos 180 minus theta. This is for magnitude. You may apply this formula either for one dimensional motion or for two dimensional motion. Any value is theta. For one dimensional motion, you may put theta is 0 degree or 180 degree. For two dimensional motion, other than 0 and 180. Then to know the direction of relative velocity, VAB is relative velocity. Let relative velocity makes an angle theta with V, and in simpler way you know the formula tan alpha is equal to VAB makes an angle alpha with V. So the formula will be VB sin theta. In place of theta we do take 180 minus theta divided by V plus V cos 180 degree minus theta. Okay. These formulas are applied for both one dimensional and two dimensional motion. Only you have to take the value of theta, considering one dimensional motion 0 or 180 degree, for two dimensional motion any other value. Okay. Then for one dimensional motion, can I erase it? These are very simple, you know it from vector analysis, right? Suppose you know the magnitude, formula for magnitude, angle between them is theta, square root of A square plus VB square plus 2 VB cos 180 degree minus theta. And direction, we know tan alpha is equal to VB sin 180 minus theta divided by VA plus VB cos 180 minus theta for one dimensional motion. For one dimensional motion, first case, two bodies moving in same direction. Two bodies moving in same direction. If two bodies moving in same direction, let's consider the same thing, body A and body B moving with velocities VA and VB, means same direction, means here angle between them is 0 degree, means VA and VB are in same direction. Just put here 0 degree, then magnitude of relative velocity is square root of VA square plus VB square plus 2VB cos 180 degree minus 0 degree. Then this comes cos 180 is minus 1, and we get square root of VA square plus VB square minus 2VB, and this comes square root of VA minus VB whole square or square root of VB minus VA whole square. So result is magnitude of relative velocity, you may take either VA minus VB or VB minus VA. Okay, which one is more? You may take, if VA is greater than VB, then VA minus VB. If VB is greater than VA, then this is VB minus VA. Okay, then about direction, tan alpha is VB sin 180 minus 0 degree divided by VA plus VB cos 180 minus 0 degree. Okay, then sin 180 is 0, 180 minus 0 degree is 180, sin 180 is 0, 0 into VB is 0, 0 by anything is 0, so tan alpha is 0, so alpha is 0 degree. So magnitude is VA minus VB. If you want to represent in vector form, let's consider this straight line represents magnitude and direction of VA. This straight line represents magnitude and direction of VB. They are moving in same direction, theta is 0 degree. Then resultant velocity is VA minus VB. Here VA, magnitude of VA is greater than VB. Then this is direction of VAB. This length of line represents magnitude of VAB, means length of VA minus length of VB. Length represents magnitude. Okay. So if two bodies moving in same direction, then magnitude of relative velocity is either VA minus VB or VB minus VA, means difference in magnitude of their velocities. Okay. Then second case I am doing in the same heading. If two bodies moving in opposite direction, for one dimensional motion we may take 0 degree or 180 degree. So if two bodies moving in opposite direction, VA and VP are in opposite direction, then theta is 180. Just put here in place of theta 180 degree. 180 minus 180 is 0, cos 0 is 1, cos 0 is 1, then this is plus, this is plus, this is plus, this is plus. Okay. So resulting velocity means magnitude of relative velocity is sum of magnitude of the velocities of the bodies, and accordingly here also for direction tan alpha VB sin 180, theta is 180, again theta is 180, sin 180 minus 180 is sin 0, sin 0 0, 0 into VB 0, 0 by anything 0, again tan alpha is 0. Again in vector form, two bodies are moving in opposite direction. Let body A moves towards along the x-axis, positive x-axis, and body B is moving along negative x-axis. This is east, this is west. You will take like this is VB, and here theta is 180 degree, and relative velocity. If both are moving in opposite direction, then relative velocity is VA plus VB or VB plus VA, means sum of length of these two lines you may take. This is VB. VA plus VB. Okay, or VB plus VA. Okay, theta is 0 degree, either direction you may consider depending upon the case. So this is motion in one dimension, relative velocity in one dimensional motion. We have used the formula taking any value of theta for one dimensional motion. We may take theta is equal to 0 degree or 180 degree, right? Okay. Then some numericals on the basis of one dimensional motion, relative velocity in one dimensional motion. And we have some collected questions. I will do all this as I have told you before. You have given me some questions, okay? And previously I have discussed it once, the basic thought. This is repeated discussion and you have collected the question, and these are the questions what I have to solve as per your demand. Okay. Then question, not a question. Okay. First, let's consider this is body A and this is body B. Okay. Body A and body B. Suppose two bodies are moving in same direction. Velocity of this body A is V, velocity body of body B is VB. Let magnitude of V is 10 meter per second and magnitude of VB is 5 meter per second. If they are moving in same direction, then theta is 0 degree. Then relative velocity VAB, magnitude of relative velocity as we have discussed is V minus V. Difference in magnitude 10 meter per second minus 5 meter per second is 5 meter per second. Okay. In second case, there are simpler examples. This is body A and this is body B. Body A is moving towards west with a velocity 10 meter per second. This is V. And body B is moving towards east. This is VB. Let's take same velocity 5 meter per second. Then in this case theta is 180 degree. This is one dimensional motion and magnitude of relative velocity is V. Magnitude of V plus magnitude of V means 10 meter per second plus 5 meter per second is 15 meter per second. These are basic thought. Then your numericals. Question number 1. I am writing your question. Okay. For other students you have given me. For other students I am writing the question. Okay. Question number 1. Question number 1. A bus is moving with a velocity of 10 meter per second. Question number 1. A bus is moving with a velocity of 10 meter per second. Bus is moving with a velocity of 10 meter per second. A scooterist wishes to overtake the bus in 100 seconds. Wishes to overtake the bus in 100 seconds. A scooterist wishes to overtake the bus in 100 seconds. If the bus is 1 kilometer ahead, the scooter 1 kilometer ahead the scooter, with what velocity should the scooterist chase the bus? With what velocity? The scooterist so chase the bus. Okay, this is your question, and I think this is a easier question. A bus is moving with a velocity of 10 meter per second. Okay, bus is moving with a velocity. This is bus. This is bus. Bus is moving with a velocity, let v1 10 meter per second, and this is scooter. This is scooter. Scooter is chasing the bus. Scooter is chasing the bus, and distance between them is 1 kilometer. You may take it 1000 meter. 1000 meters. Distance between bus and scooter is 1000 meter. With what velocity the scooter is should chase the bus? Let this velocity of scooter is v2, and it is asked to calculate v2. Then what is relative distance? Relative distance is 1000 meters. See students, relative distance is independent of frame of reference. Distance is independent of frame of reference. Okay. So relative distance is 1000 meter, and again bus and scooter are moving in same direction. Angle between velocity of bus v1 and velocity of scooter, let's velocity of scooter is v2, is 0 degree. Then what is relative velocity? As we have discussed, magnitude of relative velocity. Magnitude of relative velocity, let's take v2 minus v1, because scooter is chasing the bus and it has to catch the bus. Wishes to overtake the bus, the scooter is to overtake the bus. So velocity of scooter is should be more than velocity of bus. This is the concept. So since theta is 0 degree, then relative velocity is velocity of scooter minus velocity of bus. Okay. Then this is v2 minus velocity of bus is 10 meter per second. This is relative distance. This is relative speed. Then time is equal to relative distance upon relative speed. Now it is easier. Relative distance is 1000 meter, and relative speed is v2 minus 10. Is it clear? Okay. Scooter is to wishes to overtake the bus in 100 seconds, then t is equal to 100 seconds. That's equals to 1000 divided by v2 minus 10. Okay. Then v2 minus 10 is equal to 10, and solving this you will get velocity of scooter or speed of scooter is 10 plus 10, that's equals to 20 meter per second. Okay. Moving same direction, theta is 0 degree, and your answer is 20 meter per second. You match your answer. You have given me the question. Is the answer right? Okay. Next question. Okay. Next question. Can I erase it now? I am going to next question. Okay. Question number 2. Question number 2. Question number 2. Two trains each of 100 meter long moving with velocities. Two trains each of 100 meter long. Two trains each of 100 meter long moving with velocities 72 kilometer per hour and 54 kilometer per hour. Okay. First bit in same direction. Second bit in opposite direction. These are easier questions, and I have seen you have raised the level of questions gradually, and we will go on solving. Okay. In opposite direction, then find time taken by them to cross each other. Very easy question. First bit. Two trains are moving in same direction. Okay. Two trains are moving in same direction and length of each train is 100 meter. Okay. Just let's see. Suppose this is a train moving towards east and this is another train moving towards east. When head of one train, this is head of one, this is tail of one train and this is head of second train. Then when head of second train approaches tail of second, then it starts crossing. And when tail of second train reaches at head of first train, then it has crossed. Then what is the relative distance? Then what is relative distance? Relative distance is 100 meter plus 100 meter is equal to 200 meter. So moving in same direction, like velocity of one train is 72 km per hour and in meter per second it will be 20 meter per second. Velocity of second train is 54 km per hour, just multiplied 5 by 8. Then this will come 15 meter per second and angle between them is 0 degree, moving in same direction. Then the relative velocity is 20 meter per second minus 15 meter per second, that's equals to 5 meter per second. This is relative distance, this is relative speed, then time is equal to distance upon speed, that's equals to 200 meter divided by 5 meter per second and this is 40 seconds. Then second bit, again relative separation, moving from opposite direction. When head and head come closer, then they start crossing, and when tail and tail come closer, end crossing. Then again, relative distance is same 200 meter, but relative velocity. See, in this case, they are moving in second case, moving in opposite direction. Here theta is 180 degree. And the relative speed or velocity, magnitude of relative velocity is 20 plus 15. As we have discussed, when theta is 180 degree. 20 plus 15, that's equals to 35 meter per second. And now time. Time is relative distance divided by relative speed. And this is equal to 200 by 35 seconds. You will calculate it. Okay. And you will match your answer. This is your question, okay. You match the answer will correct. Next question. Can I reach it now? Next number comes. Okay. Question number 3. Question number 3. Two particles. Okay, two particles are at rest on a straight track. Two particles are at rest on a straight track. Two particles are at rest on a straight track and they are separated from each other by 100 meter. I am writing separated by 100 meter in some shortcut way. Separated by a distance of 100 meter. They start their motion in same direction. They start 100 meter. They start moving in same direction. They start moving in same direction. Okay. With same acceleration O, with same acceleration 10 meter per second square, with same acceleration of 10 meter per second square. What will be the relative separation after 10 seconds? What will be their relative separation after 10 seconds. Okay. In this case, two particles are at rest. Initial velocities of the particles 0 means u1 is equal to 0, u2 is equal to 0, a1 is equal to 10 meter per second square, and a2 is also equals to 10 meter per second square. Okay. And separated means relative separation is 100 meter. As I have discussed, distance is independent of frame of reference. Acceleration a1 and a2 in same direction means angle between accelerations is 0 degree. Okay. In similar way, if two velocities are in same direction, then relative velocity is v1 minus v2, magnitude of v1 minus magnitude of v2. Okay. Then two accelerations are in same direction. Then again angle between them is 0 degree. Okay. Then we have to find what will be relative separation after 10 seconds. This is initial. This is initial separation. Is equal to 100 meter. And what is relative separation after 10 seconds? I think this much is question. Okay. Then what is relative separation after 10 seconds? Left. Relative separation is delta S, and you use the general equation S is equal to ut plus half at square for relative motion. Delta S is equal to S1 minus S2. This is initial separation, which is 100 meter. Then ut, u1, both are moving in same direction. u1 minus u2 into t. Okay. In same direction, u1 and u2, u1 minus u2 plus half at square. Again acceleration a1 and a2 in same direction, a1 minus a2, as that of in case of relative velocity, into square of time. Okay. Then delta S is equal to S1 minus S2. This is initial separation. This is 100 meter. Again u1 is 0, u2 is 0 into t plus half acceleration. This is 10 meter per second square. A2 also 10 meter per second square into t square. This is also 0. This is 0. Then delta S is unchanged, means again 100 meter. Am I right? Okay. See, the simpler thing, you can estimate it without calculating. They have same acceleration in same direction, so relative acceleration is 0. Initial velocity is 0. So why displacement will change? Why distance between them is change? Distance will remain same. You can estimate it easily. Okay. Then question number 4. Two cars are moving in same direction with speed 30 km per hour. Two cars. Question number 4. Two cars are moving in same direction. Two cars are moving in same direction with speed, means same speed, with same speed. You must write same speed. With same speed of 30 km per hour. 30 km per hour. Okay. They are separated by a distance 5 km. they are separated by a distance of 5 kilometers. A third car, okay. A third car moving in opposite direction. Okay, in opposite direction meets the two cars in an interval of 4 minutes. Meets the two cars in interval of 4 minutes. Okay. Then what is asked to calculate? What is speed of third car? Okay. What is speed of third car? Okay. You just see, this is one dimensional motion. This is a car, two cars. This is car 1. This is car 2. Okay. Moving in same direction with same speed. So this is 30 km per hour. This is also 30 km per hour. 30 km per hour. And a third car moving in opposite direction. This is car 3. Okay. Separation between them is 5 km. So means this is relative separation is 5 km. Okay. The third car moving in from opposite direction, let its velocity is v, meets the two cars. First meets car 2, then meets car 1 in an interval of 4 minutes. Okay. This is time. Okay. Then what is relative velocity between C1 and C3 or C2 and C3? See, C1 and C2 are moving along this direction, and C3 is moving in opposite direction. Okay. Then angle between them is 180 degree. Then relative velocity is, if angle is 180 degree, theta is 180 degree, then relative velocity is 30 km per hour plus v. Moving from opposite direction, 30 km per hour plus v. Okay. Then time. Time is equal to relative separation divided by relative speed. Relative separation is 5 km. Relative speed is 30 plus v. Now just solve it. Then time. Interval of time is 4 minutes, means 4 by 60, means 1 by 15. 1 by 15 hour. Then in place of time I can write 1 by 15 is equal to 5 kilometer divided by 30 plus v. So 30 plus v is equal to 15 into 5, 75. Then v is equal to 75 minus 30 means 45 kilometer per hour. Yes, you have given your answer 45 kilometer per hour, and this is easier question. Same direction, opposite direction. Okay. Okay, next question is beautiful question. This is by you. Okay, very good, very good. Complete. Can I erase it now? A beautiful question is coming. Just have attention. Okay. We have given the diagram also. You have given only diagram and asked the question. Okay. This is a straight track from a diagram. Okay. This is a man. Let this man is B. You have given the name B. B is moving along this direction with respect to ground. Velocity is 8 meter per second. Okay. And this is a trolley. This is a trolley. trolley is moving with a velocity of 10 meter per second with respect to ground. Okay. So velocity of B with respect to ground is 8 meter per second. Velocity of trolley, this is trolley, with respect to ground is 10 meter per second. And a person is running on the trolley with 5 meter per second. This is a person. This is a person which is running on the trolley with a velocity of 5 meter per second. So this person is A, means velocity of body A with respect to trolley is 5 meter per second. Okay. Then what is asked? Find velocity of A with respect to B. Am I correct? Okay. Find velocity of A with respect to B. This is your question. Okay. See, trolley is moving with a velocity of 10 meter per second with respect to ground, and a man B is moving on the ground 8 meter per second, means velocity of body B with respect to ground is 8 meter per second, and a man is running on the trolley along the direction of motion of the trolley with a velocity 5 meter per second, means 5 meter per second is velocity of A with respect to trolley. And you have asked what is velocity of A with respect to B. Okay, in simpler way you may write this is V minus V. Velocity of A with respect to B, but first we have to see what is the concept behind it. Velocity of A is 5 meter per second with respect to trolley. Velocity of A is 5 meter per second with respect to trolley. But here you have to calculate velocity of A with respect to B, means velocity of A with respect to ground minus velocity of B with respect to ground. And here velocity of A with respect to trolley is given, not with respect to ground. Am I correct? Okay. So as you have given in the question, velocity of A with respect to trolley, velocity of A with respect to trolley, then how can you calculate? This is velocity of A with respect to ground minus velocity of trolley with respect to ground. Velocity of A with respect to trolley is equal to velocity of A with respect to ground minus velocity of trolley with respect to ground, and velocity of A with respect to trolley is given 5. Velocity of A with respect to ground we have to know it, minus velocity of trolley with respect to ground is 10 meter per second, then velocity of A with respect to ground is 10 plus 5, that's equals to 15 meter per second. Now it is easier, just you get it. Resulting velocity is 15 meter per second along this direction, and 8 meter per second is also in same direction. Then velocity of A with respect to B is equal to velocity of A with respect to ground is 15 minus velocity of B with respect to ground. Velocity of B with respect to ground, okay, this is given 8, 15 minus 8, then VAB is equal to 15 minus 8 means 7 meter per second. Have you given your answer? Okay, answer is correct. Okay, you may also ask, you have not asked, you may ask, you have shown that A is moving along the direction of motion. Okay. B is moving along the direction of trolley. Suppose B is moving opposite to the direction of motion of trolley. Then this is also 8 meter per second. If it would be asked, then what is your answer? See. VAB, velocity of A with respect to ground, velocity of B with respect to ground, but here directions are opposite. Opposite means in this case, this is minus. If you take opposite direction, just you have to make it positive. 15 plus 8, 23 meter per second. Okay, if B is moving in opposite direction, see, motion of trolley along with man towards east, velocity of B towards west, theta is 180 degree, then relative velocity is 15 plus 8, 23 meter per second. You may ask this also. Okay, fine. Next question. Okay, this is also a good question. Okay, you have changed your question. In place of man B, you have given a bus. Okay, this is a road. This is a bus. This is a bus. And this is a trolley. This is a trolley. This is a trolley. Okay. As is you have given in your question, this is a bus. This is driver. This is driver. Okay. This is driver D. Bus is moving with a velocity. This is driver. This is driver. This is steering. Bus is moving with a velocity of 30 meter per second. Okay. And trolley is moving in same direction. This is trolley with a velocity of 10 meter per second with respect to ground. And a man A is running in opposite direction with respect to trolley. This is man moving like this. Man A moving in opposite direction with respect to trolley with a velocity of 5 meter per second. Okay. See, this is the concept, this is the question. Bus is moving with a velocity of 30 meter per second, trolley is moving with a velocity of 30 meter per second. This is velocity of trolley with respect to ground, 10 meter per second. This is velocity of bus with respect to ground, 30 meter per second. This is velocity of A with respect to trolley, that is equals to 5 meter per second. And what is asked? What is velocity of A with respect to driver? Okay. Driver is D. What is velocity of A with respect to driver or with respect to bus? Because speed of driver or velocity of driver is same as that of bus. Okay. Velocity of A with respect to driver, and you know how to calculate velocity of A minus velocity of driver. We will calculate it. Then to get it, velocity of A with respect to ground minus velocity of driver with respect to ground. Okay, as we have discussed previously, from which velocity of driver with respect to ground is 30 meter per second. Same as that of bus with respect to ground, velocity of driver with respect to ground is 30 meter per second, and only we have to calculate velocity of A with respect to ground. See, velocity of A with respect to trolley is given, that is equals to velocity of A with respect to ground minus velocity of trolley with respect to ground, and velocity of A with respect to ground is 5 meter per second, and velocity of A with respect to ground we need it minus velocity of trolley with respect to ground is 10 meter per second, then velocity of A with respect to ground is 10 plus 5 is equal to 15 meter per second. Now your answer, velocity of A with respect to driver, velocity of A with respect to ground is 15 minus velocity of driver with respect to ground is 30 and answer is minus 15 meter per second, means it will appear to move in opposite direction. Minus means it will appear to move in opposite direction. Okay. Your answer is not matching. I think somewhere there is mistake. Your answer is minus 25 meter per second. Okay, let's see. Okay. See, A is moving in opposite direction. A is moving in opposite direction. This is the mistake. So, velocity of A with respect to trolley is 5. Velocity of A with respect to ground is, with respect to trolley is minus 5. This is in opposite direction. Trolley is towards east. A is moving towards west. This is minus 5. Then velocity of A with respect to ground minus 10. Then velocity of A with respect to ground is minus 5 plus 10. This is 5 meter per second. Okay, this is in opposite direction. You should take it negative. Now, velocity of A with respect to driver, A with respect to G is 5. Then velocity of driver with respect to ground is 30. Then this is minus 25 meter per second. Yes, this your answer is minus 25 meter per second. This was the mistake. A is moving opposite direction as compared to direction of motion of trolley. Okay. This is bit 1. This is bit 1. And in bit 2 you have asked another one in bit 2. Okay. You have collected the question. Very good question. Just you have added in bit 2. This is a monkey. This is a monkey. Okay. This is a monkey. You have added the question. Monkey is moving on the roof of bus with a velocity of 2 meter per second. Means velocity of monkey with respect to bus is 2 meter per second. So again it is asked to find velocity. Oh, the question is changed. This is minus. It is asked to find velocity of monkey. Find velocity of monkey with respect to A. Find velocity of monkey with respect to A. Monkey is running on the bus. Monkey is running on the bus. Okay. Along the direction of motion of bus, bus is moving with 30 meter per second, and on the roof of bus, monkey is running with a velocity 2 meter per second along the direction of motion of bus. And man is moving on the trolley opposite to the direction of bus, or with respect to trolley also opposite in direction. Then we have to find velocity of monkey with respect to A. Then the concept is velocity of monkey with respect to ground minus velocity of A with respect to ground, the similar concept. Okay, velocity of monkey with respect to A means velocity of monkey with respect to ground minus velocity of A with respect to ground. Okay, then velocity of monkey with respect to A, velocity of monkey with respect to ground minus velocity of A with respect to ground. I think I have calculated this once. Then let's again calculate. I have erased velocity of A with respect to trolley is equal to velocity of A with respect to ground minus velocity of trolley with respect to ground. Okay, and this is minus 5 velocity of A. This is minus 5 opposite in direction to that of motion of the trolley. Velocity of A with respect to ground minus velocity of trolley is 10 meter per second. Then velocity of A with respect to ground minus 5 plus 10. So this is equals to 5 meter per second. Okay. Then velocity of A with respect to G is 5 meter per second. Okay. Then only thing we have to calculate velocity of monkey with respect to ground. Monkey is moving on the bus. So velocity of monkey with respect to bus is 2 meter per second. Velocity of monkey with respect to bus is 2 meter per second, and this is velocity of monkey with respect to ground minus velocity of bus with respect to ground, the similar concept. Okay. Then velocity of monkey with respect to bus is 2 meter per second. This is equals to velocity of monkey with respect to ground minus velocity of bus with respect to ground is 30 meter per second. This is in same direction, so I have taken positive. So velocity of monkey with respect to ground is 2 plus 30 is equal to 32 meter per second. Then now final answer, velocity of monkey with respect to it. Velocity of monkey with respect to ground is 32 minus 5. 32 minus 5 is 27 meter per second. Yes, your answer is 27 meter per second. So far you have given, we have discussed again some beautiful questions are also there which you have not asked. Okay. A police is chasing a thief. Okay. You have to find after how much time it will catch the thief or what is distance of closest approach. Okay. And motion under gravity, okay, can be done under two-dimensional motion. You see the questions and try to answer. If not, please ask me. Okay. And this is today's class. If you will have problem in solving the numericals, you will ask me. I am ready to answer. I am ready to discuss. And thereafter we will go to two-dimensional motion, or if you ask, I will repeat again motion in one dimension. Thanks, my children. Thanks.